Hey everyone! So today, we're diving into something pretty wild in Universe Sandbox 2. I want to see what happens when we put our entire solar system right next to something absolutely massive, like galaxy-sized massive. So here's what I'm doing. I'm placing our sun here first. And don't worry, I've got the simulation paused so nothing crazy happens just yet. Now watch this. I'm going to start increasing the sun's radius bit by bit. See how it's getting bigger? And here's something cool. As the radius grows, the mass is increasing too. That's actually how it works in real physics. Bigger star, more mass. Now I'm really pushing this thing to see how big we can go. We're talking galaxy-sized here, which is absolutely bonkers when you think about it. And whoa! There it is! Our sun just collapsed into a black hole. This is actually what happens in real life when stars get too massive. Gravity becomes so strong that nothing can escape, not even light. Pretty incredible, right? The simulation is showing us real physics here. Okay, so here's a fun trick I want to try. Instead of just making stars bigger, what if we mess with their density? I'm placing another sun, and now I'm going to decrease its density drastically. In normal physics, if you make something less dense, it should expand, right? But watch what happens when we push Universe Sandbox to its limits. And there we go! The simulation just couldn't handle it. It crashed and exploded into thousands of fragments. This is actually a great example of how even computer simulations have their boundaries when we try to break the laws of physics too much. So that crash taught us something important. Too many particles can overwhelm the system. Here's what I'm going to do. I'll disable the fragments option in the simulation settings. This way we can create these massive objects without crashing the program. It's like taking the safety limits off, but in a controlled way. Now here's where it gets really interesting. Instead of decreasing density, I'm cranking it way up. Look at this. As the density increases, our sun is actually getting smaller and wow, it's turning completely black. And check out the temperature. It just dropped to 2.73 Kelvin. That's practically absolute zero, guys. We're talking about the coldest possible temperature in the universe. It's like we created the opposite of a star. Instead of hot and bright, it's cold and dark. This time, I want to show you how we can dramatically change its properties. First, let's focus on its density. Watch as I significantly decrease the sun's density. This makes it expand immensely without actually adding more mass, creating a vast, diffuse stellar object. Now let's demonstrate another incredible transformation. We can make our sun go from an extremely cold and dark state to a super hot glowing star just by adjusting its temperature. Observe as I raise its surface temperature to a fiery 7,000 degrees Celsius. See how it radiates light and heat once again? It's fully functional. With our galaxy-sized sun now perfectly stable and radiating at 7,000 degrees Celsius, let's go ahead and save this incredible object. I'll name it Galaxy Sun for easy reference. Now let's dive into its advanced properties. You can explore various metrics like its immense energy output in yotawatts, which is simply staggering. We can also observe its core temperature, which incredibly registers near absolute zero in this state. It's fascinating how the simulation can model such extreme conditions. Looking at comparisons, it naturally shows zero Earth similarity and no life likelihood, which makes sense for such a giant star. We can also see details about its magnetic fields, rotational speed, and even its composition.
Now that we have our incredible galaxy sun radiating at 7,000 degrees Celsius, let's see what happens if we introduce a familiar celestial body to its extreme environment. Let's place Mercury right next to it. As you can see, the moment Mercury approaches our colossal sun, its surface temperature skyrockets almost instantly, reaching unfathomable levels, nearly 100 million degrees Celsius. However, despite these extreme conditions, Mercury doesn't simply vaporize. Instead, it becomes this glowing star-like object, continuing its orbit. This is quite peculiar. But now for an even grander experiment. Let's introduce Stephenson 218, considered one of the largest stars ever discovered in our universe. Watch the sheer scale as we place Stephenson 218 next to our galaxy sun.
And look at that! Our custom galaxy sun is so enormous that it makes Stephenson 218 look like a tiny baby next to it. It's an incredible demonstration of scale.
Now, let's go back and observe Mercury's unusual behavior in more detail as it orbits our galaxy sun. Scientifically, under such extreme conditions, Mercury should instantly turn to plasma and vanish. Its peculiar survival and transformation into this bright star-like appearance is likely a fascinating glitch within the universe Sandbox engine.
Okay, so in the next video, we'll use our creation to build a custom solar system with this galaxy-sized sun and see what happens to our planets. See you in the next video, guys.